All right, let's take a look at the pH scale right here. So in 1909, there was a Danish chemist by the name of S.P. Sorensen, and he came up with a scale, Sorensen scale, which we call the pH scale. pH stands for potency or power of hydrogen scale. It's a log scale. That means for every pH value, so if I'm looking at a pH of 1 versus a pH of 2 or 3 or 4, every pH value difference is a power of 10, okay, in terms of the concentration of the hydronium ions. And they tell you that right here. So if you are calculating the pH of something, you need the hydronium ion concentration because pH is equal to the negative log of the hydronium ion concentration. Be careful when you put this in your calculator. This negative here is on the bottom right underneath the 3. This is not the subtraction key. If you use the subtraction key, it will say error on your calculator. Okay? Let's take a look at the next page. Okay, let's talk about measuring pH. So generally speaking, pH is measured with a pH meter, and there are acid-base indicators as well. We've used one. We used phenolphthalein. And let's come down here and let's take a look at the quick check. So what I'd like you to do is I'd like you to calculate the pH values for orange juice, milk of magnesia, and stomach acid. And then I'd like you to do number 2. And we will go over the answers. Okay, so work on those with the person sitting next. Okay, what'd you guys get for orange juice? 3.5. Okay, milk of magnesia? 10.6. And then the stomach acid? 4.5. Yeah? 1.5. Okay. All right, cool. We all agree? Okay, now for number 2, it says, during a titration, the pH decreased by 5 units from 8 to 3 at the equivalence point. Did the hydronium ion concentration increase or decrease? pH went down. If my pH went from 8 to 3, is it acidic or basic? Acidic. It's acidic. So then did hydronium go up or down? Had to go up. Right? Because acids release hydrogen ions. Hydrogen ions are hydronium ions. Okay, so hydronium had to go up. And then by how much? Okay, so every pH unit is a power of 10. So 10 to the what? Yeah, 10 to the 5th. Turn to the next page. Okay, if you have the pH and I ask for the hydronium ion concentration, this is how you will solve it. You'll take 10 to the negative pH. This is called the anti-log. Have you guys done these, logs and anti-logs? Because they took it out of the curriculum, I think. Okay, so this is what you would use. You don't have to memorize this equation. I will give you this equation on a quiz or a test. Okay? All right. So let's take a look at a sample problem. So on the sample problem, it says the pH of a beaker of lemon juice is 2.31. Calculate the concentration of hydronium ions in the solution. Okay, so if they want hydronium, but they gave me pH, which equation would I use? The negative log or 10 to the negative pH? Yeah, so the hydronium ion concentration is equal to 10 to the negative pH. So you're going to put this 2.31 here, where pH would go. So you would put in your calculator 10 to the negative 2.31. Will you make sure that you can get this answer so that way I know you can do it on the homework? Make sure you get 4.9 times 10 to the negative 3. You got it?
It gave us like a decimal.
Okay, it gave you a decimal. Okay, that's fine.
Still makes sense.
That's fine. You would have to convert, so it gave you 0.00489?
Yeah.
Okay, so you would have to just convert it into standard scientific notation, which we did earlier this year and which you did previously. So this is 1, 2, 3, move it over 3 decimal places. Okay, and that's how you get the 4.89 or 4.9. Okay? If you want to convert that in your calculator, you have to use the mode key. And you have to go to sci mode and hit enter so that it automatically converts it for you. Okay? Are we okay with this? Can I go on? Okay. Let's come over here. Why don't you fill in this table with the person sitting next to you for practice, and let's see what you guys come up with. What did you guys get for the first one?
4.3.
Okay. Next one.
4.57. Oh, 4.57. That's 4.6.
Whatever.
-4.
Okay, that's fine. 4.57, 4.6 is cool. Okay. Next one, what'd you get? 10.2-ish?
Yeah.
Okay. How about the next one?
8.81.
Times 10.
-7.
-7. How about the last one?
2.46.
Time, is there a times or no? No? Okay, so just to be clear, when you were calculating the pH, you all went negative log of the hydronium ion concentration, yes?
Yeah.
And then over here, you did 10 to the negative pH. Okay, can I go on?
Mhm.
Awesome. Okay, let's come down here. Okay, now, if we want to take a look at solutions with hydroxide ions, a log way of calculating something equivalent to pH was to get the pOH. So pOH is equal to the negative log of the hydroxide ion concentration. So again, do not memorize this equation. I will give this to you if needed on a test or on a quiz. And let's take a look at the next page. Let's turn. I went too far. Here?
Yeah.
Okay. All right. Now, the pH plus the pOH, don't highlight that one. Sorry, I was highlighting the wrong one. The pH plus the pOH is equal to 14. I will give you this equation. Do not memorize it. Okay? Okay. Now, if you were to plot the hydronium and hydroxide ion concentration, since they're inversely related, the graph should look just like the graph of pressure versus volume from the gas chapter, and it does, right? This looks really familiar, and that's because these two are inversely related. Okay, so I would note that. This is just rehashing something I taught you in a previous section. And then, can I move on? Okay. Down here at the bottom, they relate pH to pOH and whether the solution is neutral, acidic, or basic. So if it's neutral, they will equal each other. That means they will both be 7. Okay? If the pH is less than the pOH, then the solution is acidic. If the pH is greater than the pOH, then the solution is basic. Okay? Take a look at the next page. Okay, figure 12.4.4 gives you an outline of what you should do. Like if you're confused, let's say that you are given the pH and they're asking you to solve for the hydroxide ion concentration, okay? What you could do is you could take 10 to the negative pH to solve for the hydronium ion concentration, and then you could use this equation, which we used in the previous section, where it equals 1 times 10 to the negative 14 to calculate the hydroxide. So this is just sort of like a flow chart for helping you determine an unknown. Does that make sense? Okay, I'm not going to go through the whole thing. I think you guys can follow along with the arrows, okay? Okay, now, down here, sorry, you do not memorize this. Think of this as a cursor that you can move to the left or to the right. So if they're asking you for pH and pOH, and they give you a hydronium ion concentration, then these all go together. So if your pH is 1, like it is here, your pOH would be 13. That's because they add up to 14. And then if they want the hydroxide ion concentration, you could just get it here. Does that make sense? You may never use this. All right, turn to the last page. You like this section? Yeah. It's kind of short, to the point. Okay, here's what I want to do. I want you to fill in table number 1 here with the person sitting next to you. So this is 10 to the negative pH, this whole column. This whole column is 10 to the negative pOH. Did you guys write that in so that you knew what you were doing? Yeah. This is pH plus pOH equals 14. Does that help you?
Yeah.
Okay. So then is the first one acidic, basic, or neutral? Yep, acidic because the pH is less than 7. Just giving you that note. Okay, tears.
Oh, I know this one.
Okay, so in this case, you would have to do the 1 times 10 to the negative 14. So 1 second E negative 14 divided by 3.98, second E negative 8. What'd you get?
Oh, okay, so we didn't do that actually.
Right, okay. Yeah?
Oh, I got that.
What?
I did it.
What?
I did.
Okay.
Yeah.
Okay. Okay. 6.6. Okay, so, all right. So this one was 1 times 10 to the negative 14 equals 3.98 times 10 to the negative 8 times the hydroxide. And so we just divided by both, and that's how we got that. And then over here, you did pH is the negative log of hydronium. And then for pOH, you did negative log of hydroxide, right? Okay. And then your pH is 7.4, so this would be basic. Okay, blood.
3.98 times 10 to the negative 8.
Okay.
Yeah, and then 2.51 times 10 to the negative 7.
Then.
And then 6.6.
Okay. And this is same. No. Basic. Okay. Milk. Anyone? Yeah. What'd you get? So you did 1 times 10 to the negative 14 equals hydronium times 3.16 times 10 to the negative 8. Yeah? You got what for the pH? Okay. And then what'd you get for pOH? Do 14 minus 6.5. 7.5. This is an acid because the pH is less than 7. Hold on 1 second.